Okay, in this video we are going to be going over selection sort. So we're going to start with a demo. So here we have a list of unsorted values for 1, 2, 7, 6, and we're going to put them in ascending order using the selection sort algorithm. The way the selection sort algorithm works is you start by locating the minimum value. And so let's say that this is our unsorted array. Everything that's in blue. So you search that unsorted array for the smallest value, and then you swap that smallest value with the first value in the unsorted array. So we're going to swap 1 and 4. So now we have one element that's in place, and then we have 4 remaining elements that need to be placed in order. So we just repeat that process with the unsorted portion of the array, which is this gray portion. So we find the minimum value, which is 2, and then we swap the 2 with the first value in the unsorted array, which is 4 in this case. So we're going to swap it. Now we have 2 in place, and then we have 3 left to sort. We're going to do it again this time. Again, we're doing this with just the unsorted portion of the array. So we're going to find the minimum value, which is 4 now. And this value is in place, so it doesn't need to be swapped. Now we're going to continue on. So we have 3 in place, 2 left to sort. We're going to find the minimum value, which is 6. And we want to move that in front of the unsorted array. So we're going to swap it with 7. And now we have 4 in place, 1 left. When we look at the 1, that's the last one, so it's in place. It's the smallest in the group, so smallest in the unsorted group. So now we have all of our elements in place. So selection sort, the algorithm works by finding the smallest item in the list and exchanging it with the leftmost unsorted element, and you just repeat that from like the first of every unsorted element, the first of every piece of the unsorted element or unsorted portion of the array. This is the algorithm that when I first needed to sort something and I just thought about how you would do it, I thought about it before I looked at any algorithms. This is the way that I wrote the algorithm. So I wasn't thinking about efficiency or anything. It was just like I needed something to be sorted, and I was like, how would I do that? And I just thought about it, and this is the way that I thought about how to sort an array of data. This is what the code looks like. So let's say that we have something like this. 5 values, 3, 2, 1, 5, 7. How does the algorithm work? So I is going to go through all the elements. And it's going to start the first one, and it's going to find the minimum value of everything behind I. So it initializes end to the value of I, and then j is going to be searching everything behind it. And all this does is just a minimum algorithm, so it just compares every j value with every end value, and if it finds a j value that's smaller, it replaces it. And ultimately, after it runs, the algorithm will locate that, so ultimately after it runs, in this case, it's going to find that this is end, right? Because that's the smallest value. And then all it's going to do is swap these two, and that's what this swapping algorithm does. So it's going to continue to do this for every I all the way up to the last element in the array. And you'll notice here that there's a little if statement that if the smallest element is the 1 itself, then it doesn't have to do the swap. Which was a case in the demo a couple times, right? So 4 didn't need to be swapped, so that would skip the swapping part in that portion of the code. So let's talk about the big O of selection sort. So you can see there's 2 nested for loops, so you're probably thinking n squared. Well, let's think of the best case scenario. So we saw that in insertion sort, if something was already sorted, that the algorithm performed in ON because it didn't perform the swapping as it went backwards. Selection sort doesn't work that way because in order to find the minimum value, the only way you know you have a minimum is if you check all of them, right? So unfortunately for selection sort, the best case scenario is still n squared because this always has to happen. Worst case is n squared as well, which is again pretty much always happening, right? Because you're always checking all of them. And then the average case is also n squared. Now this isn't actually n, right? It's like n and then n minus 1 and then n minus 2 all the way to 1. But when you actually analyze that, it converges to n squared. And so we call loops that are n loops with like a decreasing n loop inside, we still call that n squared. So this algorithm is quadratic. So what do we really care about? We care that it's a quadratic growth algorithm, which means the same as before. If you double the number of elements in V, it's going to take 4 times longer on average to run the algorithm. And so you have to imagine if you continue to double and continue to double, how that's going to grow. The growth looks just like that plot, and I'll show the growth plots and do a comparison of all the algorithms in the last video. So that is all for selection sort.